Good morning, everyone. We were discussing about the addressing scheme used in network layer. So, in the previous lecture, we have seen IPv4 addressing, in that class full addressing and the subdivisions like class A, class B, class C, class D, as well as class E. Hope that you have gone through that video. With that, we'll move on to the second category under IPv4 addressing, which is called as classless addressing scheme. As I said in the previous lecture, classful addressing is a one wherein the prefix is of fixed length. That is, in case of class A, the prefix length or the network length or the address was fixed to 8-bit. Under class B, it was the prefix was of 16-bit. Under class C, it is of 24-bit. So the classless addressing scheme, the length of the prefix is not fixed, it is variable. So we'll go through classless addressing scheme today, and we'll solve few problems related to classless addressing scheme. As I said, under classless addressing scheme, there is no fixed prefix, that is no fixed network address. So based on the requirement, the internet authority will allocate or will issue a block of addresses to the needy or for an organization. But there are three restrictions for allocating this block of addresses. So whenever the address is allocated to any of the organization, the first thing is the whatever the address is allocated, the address block must be continuous. So whatever the address is given to the organization, it is continuous address. Second thing is the number of addresses in a block must be power of 2. So as I said, when the block of addresses is allocated, it should be always power of 2. It should be 2, 4, 8, 16, 24, 256, 1024, so on. So it should be the power of 2. And the third one is the first address whatever has been allocated to the organization should be divisible by the total number of addresses. So the first address whatever it is given, that will be or that should be divisible by the total number of addresses allocated to that particular organization. With these three restrictions or with this three condition, a block of address will be allocated to the organization. As you can see in this example, a block of 16 addresses has been granted to a small organization. That is, a small organization which requires 16 addresses has been allocated. The first address is given as 205.16.37.32. So this is the first address, followed by, as per the first condition, the address should be continuous. So you can see this is 32, similarly 33, 34, and it goes up to 47. So total 16 addresses from 205.16.37.32 to till 205.16.37.47. So total 16 addresses have been allocated, and as per the condition, all the addresses are continuous. And since it is 16 addresses, it is the power of 2, that is 2 to the power of 4 is equal to 16. So once again, the number of addresses which has been allocated is the power of 2, and the first address if you take, it is divisible by 16. So this is how the addresses have been allocated to a given or any organization. So in case of classless addressing, as I said, there is no restriction on the length of prefix, so it is variable. So whenever the address has been given, the address usually represented by the format x dot y dot z dot t slash n. We also call it as mask or slash notation. So x dot y dot z dot t, which is going to define one of the addresses in the block of addresses allocated, and slash n, what you can see here, slash n will define the mask. It is going to tell, or it is going to indicate the length of the prefix. For example, if you take, this is the represented in dotted decimal notation 12.24, that is 24.76.8 slash n. So in this 24.24.76.8 is one of the addresses, or the beginning address or the ending address of a particular block, and 8, that is slash 8, indicates the prefix length. Similarly, you can see here 23.14.67.92, where this is one of the addresses among the block of addresses, and 12 will indicate the uh, prefix length. What is this prefix length? Prefix length is nothing but the network address. So the 12 bit will represent the network address, remaining bits will represent the device address. So as I said, this n, that is slash n, will indicate the prefix, and the remaining will be the addresses. So now let us see how the first address as well as the last address can be calculated based on the given one of the address. So in block of addresses, if one of the address has been given, then it is easy to find out the first address in that block as well as the last address in the particular block. We'll see how it is. So whenever the address, one of the address is given, as I said, in the address slash n, which represent the prefix, so that is the address of the network, and the remaining 32 minus n bits, so whatever the 32 minus n bits will be there, that bits you have to add zeros, or you have to make those bits zero to get the first address. I repeat, whenever one particular address is given, at the end slash n will be given, that's n indicate the prefix length, and remaining whatever the bit, so in this case n bits are prefix, so total bits in the given address is 32 bit. So remaining 32 minus n bit, whatever we call it as suffix. So if you make all the bits in suffix equal to 0, then it will be the first address of that particular block in case of classless addressing. Similarly, to find the last address in the given block of address can be calculated or found out by taking the address, the prefix as it is, that is n bit, and whatever the remaining 32 minus n bit, that is the suffix, you have to make all the bits equal to 1. So if you make all the suffix equal to 0, that indicates the first address in that block, and if you make the suffix bit is equal to 1, that is all the bits equal to 1, that is going to represent the last address in a given block of address. Hope this is clear. So with this, we'll take one example and we'll calculate how the first address, how the last address can be calculated when one of the address has been given. Yeah, here is an example. So the problem says a block of addresses is granted to a small organization. We know that one of the address is 205.16.37.0 0.39/28. So what is the first address and last address in the block? So the problem says a block of addresses has been granted to a small organization, and one of the address has been given as 205.16.37.39/28, where slash 28 nothing but the mask, and we need to calculate the first address as well as the last address. So first we'll take this address which is given in dotted decimal notation. Let us represent in binary notation. So 205 is nothing but 1100 1101. 16 is nothing but 0001 0000. 37 is nothing but 0010 0101. And 39 is nothing but 0010 0111. And as I said, the slash 28, that is 28, that is n, which indicates the number of prefix, that is the bits in prefix. So first 28 bit will remain same as the given address, and remaining 32 minus 28, that is the last 4 bits. Okay, 29, 30, 31, 32 bits will represent, or using that we can find out the first as well as last address. So to find the first address, first we have to set 32 minus 28. 32 is the number of bits in the given address minus the mask 28. That many bits we have to make 0. So it is 1100 1101. So this is same as this. 0001 once again this is same as this, that is 16. 0010 0101, that is same as the earlier one. Then 0010, you can see it is 0010, and last 4 digits are 0111. So 32 minus 28 is 4. So you have to make these 4 bits equal to 0. So we have made this 4 bits equal to 0. So the address whatever we get is 205.16.37 dot, this is equal to 32. So this will be the first address in the given block. So similarly, let us find out what is the last address in the given block. Similarly, so the last 4 bits, that is this 4 bits, if we make all bits equal to 1, that is you can see here, if we make all these 4 bits equal to 1, that will give us the last address in the given block. So this is what the address given, so one of the address in the given block. Now so 28, sorry, 32 minus 28, that is 4 bits. So last 4 bits we have to make it 1111. So this will be our last address in the given block. So it is nothing but 205.16.37.47. So in this particular problem, the first address is 205.16.37.32. Then the last address is 205.16.37.47. So we have total 16 addresses in the given block, and the one of the address in the given block is 205.16.37.39. So hope it is clear. So whenever a block, one of the address in the given block is given, so you can directly calculate the number of addresses in the given block, as well as you can calculate the first address as well as the last address. So to calculate the total number of addresses in the block, just take the number of bits, that is 32, subtract the mass, that is 28. Here you can see 28. So 32 minus 28, it is 4. Take 2 to the power of this, so 2 to the power of 4, that is 16. So that represent the total number of addresses in the given block. Okay, so in this case it is 32 minus 28, so it is 4. So 2 to the power of this difference, that is n minus number of that is total number of bits minus the mask will give you the total number of addresses in the given problem. So according to that, in this we have total 16 addresses. So similarly, we have one more problem which says a classless addressing is given as 167.199.170.82 slash 27. We can find out the above three piece of information as follows. That is, in this, once again, we are going to calculate the total number of addresses in the given block, also the first address and also the last address. As I said, the total number of address in the given block is calculated based on the formula 2 to the power of 32 minus n. 2 to the power of 32 minus n, in this case it is 27. So 32 minus 27 results in 5, that is 2 to the power of 5, which is equal to 32. So in this particular block, so there are total 32 addresses. So to calculate the first address, as I said, so we have to make last 5 bits equal to 0. So address given is 167.199.170.82 slash 27. So when I represent that in binary notation, it is 10100111. 199 it is 11000111. 170 it is 10101010, and 82 it is 01010010. So as I said, so 32 minus n, that is 27, difference is 5. So in the given address, the last 5 bits, that is this 5 bits, we have to make it 0. So when we make all these 5 bits equal to 0, we end up with the address 167.199.170.64. So this is the first address in the given block of in the given block. Similarly, to find the last address, as I said, we need to make the 32 minus n bits, the last those many bits to 1. So 32 minus n, that is 5. So in the given block address, last 5 bits we have to make is equal to 1. So in this particular problem, it is 167.199.170.95. So there's a mistake here, it has to be 10010010. So this last 5 bits we are making equal to 1. So note down, so there's a small mistake here, this has to be 01010010. So that is this address. So we'll be making this 5 bits equal to 1 in order to generate the last address. So last address we get it as 167.199.170.95 slash 27. So this is how we calculate the total number of addresses in the given block, as well as the first address as well as the last address. So you will be getting a problem based on this. So whenever a random address in a block of address will be given, so using this formula you need to calculate the first address, the last address, and the total number of addresses available in the given block of addresses. The next topic is network address. So we know, in whenever organization is connected to an internet, so it can allocate any address to that connecting organization to a internet. So it can allocate any address to a device that need to be connected to internet. So usually the very first address is called as the special address or the network address, and this is going to define the organization network. So the whatever the first address we take, we call it as the network address, which is going to define the organization address. From that, all other devices in the network will be connected within the given organization. As you can see in this diagram, so you have a router. So this network is connected to this router using this interface, that is interface 1. Your second network, once again within that there are multiple devices connected to this network, and this network has been connected to this router using interface 2, and similarly the M here. So this whatever is connected interface, the network to the router, we call it as network address. So usually that will be the first address in the network. So as I said, whenever an organization require a block of addresses, that is in case of classless addressing, so a block of addresses will be allocated to that particular organization. Usually, the responsibility of address allocation has been given to ICANN, which stands for Internet Corporation for Assigned Names and Address. So, this is the organization which is responsible for allocating the addresses. But usually, it does not allocate the address to the individual organization. Usually, it will be done by making use of ISP. So ICANN will allocate a large number of addresses to ISP, that is Internet Service Provider. So this ISP, what it will do is it is going to divide this entire block into smaller sub block, and based on the requirement of the organization or the customer, that will be allocated. Or in other word, an ISP receives one large block to be distributed to its internet users. So this is called as address aggregation. So it is a duty of the ISP to take the addresses from ICANN, and its job is to distribute it to the organization or to the customer based on their requirement. Let us see how ISP will allocate these addresses. Assume an ISP has requested a block of 1000 addresses. Since it 1000 is not power of 2, the number of addresses it is going to granted is 1024 addresses. Hope you remember, I have told in the previous slides that the number of addresses allocated will be always the power of 2. So since 1000 is not the power of 2, so it will go with 1024 addresses will be granted. So since it is classless addressing, there is no prefix length. The prefix length is calculated by using the formula n is equal to 32 minus log 1024 to the base 2. So what is this 1024 is nothing but total number of address granted, so that is 1024 to the base 2. So 32 minus log 1024 base 2 is nothing but 22. So the address will be something like 18.14.12.0 slash 22, where slash 22 or 22 is indicating the mask or the length of the prefix. Let us take one example related to this. An organization is granted a block of addresses with the beginning address 14.24.74.0/24. The organization needs to have three subblocks of addresses to use in its three subnets. So one subblock of 10 addresses, one subblock of 60 addresses, and one subblock of 120 addresses. So design the subblock. So this problem says a block of addresses has been allocated and the beginning address has been given, and it is given as 14.24.74.0/24. So the length of the prefix is 24, and it has to be divided among three subblocks, and the one block requires 10 addresses, second block requires 60 addresses, third block requires 120 addresses. Total addresses required here it is 10 plus 60 plus 120. So total it requires 170 addresses. So as we know, the number of addresses allocated to a particular block is always power of 2. So since it is 170, so it is going to, that is ISP is going to grant total 256 addresses against 170 addresses. So total number of addresses allocated is 256. So the first address will be 14.24.74.0/24. 2, the last address allocated will be 14.24.74.255. So 0 to 255, total 256 addresses has been allocated. So the mask will be n is equal to 24, and that has to be allocated to 3 blocks. One requires 10 addresses, one require 60 addresses, and one require 120 addresses. So once again, here it cannot allocated as per the requirement. Instead it should be always power of 2. So where one block requested for 10 addresses will be granted 16 addresses. A block which requested for 60 addresses has been granted 64 addresses, once again power of 2. And one more block requested for 120 addresses, it is granted with 128 addresses. So if I take the first address, it is 14.24.74.0. so since it is n is equal to 128, so I am going to get the mask is equal to 25 in case where it requires total 120 addresses. So according to that, the first address will be 14.24.74.0/25 till, since it requires 128 addresses, so it goes up to 14.24.74.127/25 from 0 to 127. So total 128 address. Whereas for the second case, it starts with 14.24.74.128. Remember, for the 128 address here, the last address was 14.24.74.127. So this once again requires 64 addresses, the second block. So address starts with 14.24.74.128/26 till it goes up to 14.24.192.0. Here remember, the mask has increased, so the bit here varies from 74.128 to 192.0, total 64 addresses. And the last one, it is 14.24.192.0/28. So in the previous case, the address is from 14.24.74.128/26 to 14.24.191.255. So the previous address here, it is 14.24.191.256, sorry, 255. So the next address will be 14.24.192.0/28. So from here, once again, the 16 addresses will be allocated and the mass will be equal to 28. So since the total number of addresses allocated is 256, so remaining 48 addresses will be unused in this particular example. So even, because as we know, the number of blocks allocated will be power of 2 and the requirement was less than that. So according to the distribution from ISP, it is 128 addresses plus 64 plus 16. So total it will be, so the total will be equal to 208. So 128 plus 64 plus 16, so total 208 against the allocated 256. So 48 addresses are unused. Hope you followed how the addresses for the sub block will be allocated in by making use of ISP here.